So first of all, we have the LinkedList. We are starting with the first of all we have a node data previous next same and making the head pointer as the global variables because we are going to use that over the whole of the function. Then search is easy. We are taking the position as -1. If it returns -1, then we don't then we didn't get the position, or else if we find the data. So what we do, we just insert the position, fill up the position with the I. That is the position we get because I is incrementing every loop, like after every loop finishes it likes increments one time. So that's it. We have the insert function. Traverse is getting the address of the head. If traverse is null, that also means head is null, so we have to create a new node. Traverse is getting the new node, data is element, next is null, previous is null, head is getting the address of the traverse. Easy. So else inside the else, what we are doing while so we are moving the traverse such that traverse is pointing to the last node. So when it's pointing to the last node, we are creating a new node and making the links. That's it. It's like easy. So we delete the element we want to delete. First of all, remove is getting with the int minimum, the minimum value of the integer. So if it returns int minimum, so we know no element was removed. Else, if position is -1, first of all we are taking POS, which is a variable which will contain the position of the element. Linear search. We are doing the linear search for the element. If the position is not equals to -1, that means we have find the element that needs to be removed. If position is 1, that simply means because it's a special condition, because we have to shift the head. So we are just making the same things, taking the t, making it head, and if not if, and we are freeing the t because we have to free up the space. Else we are making a pre-node. Pre-node means previous node and the next node. So I'm moving this while loop is moving such that the next node is pointing to the element that needs to be removed, right? And previous node is pointing to the previous of the next node. Now next is pointing to the node that needs to be removed. So we have two conditions, whether we have to delete last node or delete in between node. So let me explain you. For instance, we have to delete in between node, right? Something is like we have previous nodes. Okay, so we know next is pointing to the node that needs to be removed and previous is pointing to the previous of the next. So it's in between node, right? So what we have to do, we have to make previous next. So basically this needs to be removed, right? So previous next is equals to next. So this link has to be created if it's between, and next which is this next previous must be previous node. So this is the things we have to do for in between node. Or else what we need to do for the last node, we know next will be pointing here, this is null and this is previous. Basically we have to do free the next and make the previous node next null. That's it. Like it's easy, no need to do all that stuff. So for deleting last node it's like easy. So we have to make previous next is null, or else I'll just show you the how the links are getting. So we have to free the next. That's it. For printing it's easy. From there are like two choices if you want to print from start to end or end to start. So that's it. Like so this is the main function, same and while loop. Then run it. 2 1 3 1 4 1 5. So basically I did put the 5 elements. Let me. So from start to end is 1 2 3 4 5, then null. If I want to like print from end to start, that is 5 4 3 2 1 and null. So we can see 5 4 3 2 1. Now if I want to delete 5, let's delete 5. So 5 removed. Let me display it. We can see 5 got removed. And now if you want to print from end to start, so what we're gonna do, like 2, you can see 5 was removed. Now if I want to delete 2, okay, let's say 1, the first most element, like delete 1 removed. Now let me display it. 2 3 4, that's it. Now if I want to linear search 2 3 4, so 2 is at position 1, we know. Find what yeah, you can see. Now if I want to search 5, that's not present, right? So not found. That's for the doubly linked list. Now we are moving on to the circular linked list. So circular linked list is nothing but the last node is pointing to the head. That's it. All same, everything is same. Just last node is pointing to the head. That's it. Linear search is easy. We are moving traverse such that it doesn't such that like when the traverse meets the head, because it's the last thing. Wait, let me show you. Chapel. Wait a sec. Okay, so for the circular linked list, some things are like this. This is the head node. So last node is pointing to the head. It's easy. In single linked list, what used to happen, that it was pointing to null, but not now. It's pointing to head. So it's like easy. We are doing linear search till we found the element. That's it. For insert is the same. Previously we were traverse was wait, let me show you. Previously what we were doing, we were moving the traverse such that it points on the last node. So its condition was traverse is not equals to null, because it was doubly linked list. Now it's circular, so we have to put the head, because the last node is pointing to a head, right? So it's easy, like we have to make the same links. So let's move on to delete position. So it's the same position taken by the linear search. A position is 1. So one thing what we have to do, traverse is taking. So where, let me show you how the thing works. Like if I show you, so if I want to delete like first position, right? If I want to delete head, what things I need to do? The last was pointing to this, right? So what we have to do, we have to make this point to the this, because we know this is getting deleted, right? And move head to the head next. So these are the things we have to do, and free head. That's it. So this is the condition. This is getting deleted. The last node's next pointer is getting updated to the heads next, and the heads is also getting updated. So these are the things we are getting the. So I'm moving. It's like the same. We are moving the while it's not head. While traverse is not pointing to the last node. As soon as traverse is on the last node, we are making traverse next to the head next. So what we are doing, traverse. This is traverse, right? Traverse next is equals to head next. Head is this, head next is this. So traverse next is head next. So that's it. And moving the head and freeing the traverse. That's it. Or else condition is all the same, nothing different. And print is the same way. What's that? Let me like run it. 1 2. So we have like 4 elements, right? If I display it, 1 2 3 4 elements, and 4 after 4 it's pointing to the first node, that is 1. If I want to delete first, like if I would want to delete 1, let's delete it. So 1 got removed, right? Display it 2 3 4. If I want to delete last node, let's delete it. Where? Okay, let's delete. So we know 4 got removed and 2 3 is pointing to the first one. That's it for the circular linked list. So we are moving to the implementation of stack linked list. So push is the same, because we are putting the element at the last node. So this push function is same, no need to change, right? Pop function is got changed. So pop pop means deleting the last element, right? So how we are doing that? First we are taking int remove, which will take the int minimum. Same struct node traverse is pointing to the head. If traverse is null, that is we don't want to remove anything, that is the stack is empty, so we simply return. Else if traverse next is null, that is head is the only node present. So what we have to do, remove we have to free the head plus remove gets the head data, and head gets null because it was the last element, right? It was the only element present, or else we have like more than one elements present, so these things happen, right? So the way we are doing that is traverse is pointing to the last element, right? And previous is pointing to the second last element. So wait, traverse is pointing to last element and previous is pointing to second last element, right? So traverse is pointing to last and so and previous is pointing to the second last element, and forget this, and remove is getting that traverse data, and previous next is getting null. That's it. No need to like think more. Let me show you again how the things are happening. So traverse is here, previous is here. We are making previous next is null, and traverse we are freeing it, like so. That's it. It's just nothing, and else print and the same to value. Let me show you. So we have let me display. So this is the, why do I have to put null? Okay, I will remove it. So this is the same things. Now if I want to pop, so 5 will be popped, right? Let me pop 5. See, it now 5 got popped. Now it's only 1 2 3 4. Now again pop, 4 got popped, right? 3 got popped, 2 got popped, 1 got popped. Now things are empty, stack is empty. Now again if I want to insert 1 2 1 3 1 4, so if I want to again display, pop 4, pop 3, pop 2, pop 1, empty. That's it. Now we are moving on to the queue. NQ is same, adding at the last. It's the exact same. Push and NQ are the exact same because we are putting in the putting at the last. And DQ is the most like easiest thing you can see. So same, removed is getting in minimum. If head is not equals to null, that is we have elements. So we just need to like shift the head by 1. Head is equals to head next, and just freeing that T, which will contain the head's address. That is return removed, print. That's it. So let me again. So if I want to display 1 2 3 4, okay, this is the queue. If I want to add 5, so 5 will be added just before 4. So let me in queue 5 got queued. You can see. And if I want to like DQ, that is 1 will be DQ'd, right? 1 got DQ'd. Let me display. See, 2 3 4. Now 5 is only the element which is left, right? If I want to DQ, 5 got DQ'd. Now I can't DQ no more. So that's it. We got the four different programs. So thank you.